We are doing May June 2021 paper 4.2. This is a linked list question that we're supposed to do with object-oriented programming. This is going to be a bit of a tough question, so we have to plan it accordingly. In the first part, they have given us a dummy linked list in which we have some data and we are supposed to copy the data into our code and then we have to implement this. Let's begin. First of all, they're telling us that there's going to be some sort of a record type that is called node. And in our context in Python, you have to use a class for it. So we'll call it class, and then there would be a node here. And then I'll have to create a constructor defined in it. And then there would be a self first parameter, and then we'll have data, and then we have next node like this. And we can set them to the values. We have to keep in mind these values might be used ahead in the parts, so we have to stick to these. We are going to assign them with some attributes. Self.data is equal to data, and then self.next node is equal to next node like this. All right. Then they're saying declare 1D array of type node with the identifier linked list and initialize with the data shown in page 2. Okay. So we're supposed to create an array with all the values shown here. For that, we have to go into the main program, main, like this, and then we write linked list is equal to. So inside this, we'll create multiple objects. You can do it inside the square brackets, or you can do them separately, line by line. So we'll have, in fact, it would be a better idea to do it here. Otherwise, we'll have to assign some variables to each of them. So we have node 1,1, which is data, and the next node, then we have 5, 4, so on and so forth. So we have to just replicate this. Here we go. We have the complete linked list typed here. Then we are setting the start pointer to 0, and we have the empty list set to 5. We have to use the same names as given in the question. No variations in that. Okay, now in the next part, they're saying that you have to write the procedure called output nodes. So let's write that, define output nodes, which will take the array, the name of the array is linked list, then the start pointer as parameters, and then it will output all the values in the node from the linked list following the next node values. Okay, so what do we have to do here is that we'll start from the index 0. At index 0, the data is 1, and the next node is at 1. So we go to 1, then we read the data. The next node is at 4, so we go to index 4. Data is 2, and then the next value is at index 2. So we go to index 2, we read 6, and then the next is 7. So we go to 7, 56, then 3, we go to index 3, and now -1 is finally the end of linked list. And this is what we have to do. We have to print all the values as per the non-linear linked list order. Okay, now how do we do this? We always start from the start pointer, and we'll keep on iterating until we see a new next node that is set to -1. And until that point, we will keep on outputting the data values of the linked list. And we simply have to write the code for this. It's actually the easiest part of the question. So what we'll do is we'll start from the current pointer, or the current pointer is set to the start pointer. We'll keep a copy of it in the current pointer. So current pointer will also be set to 0, which will be data where data is set to 1, and we'll use a while the current pointer is not equal to -1, which means that it is not the end of linked list yet. As long as that is not the case, what we're going to do is we're going to print the data values. So I'll write print the current linked list, current index, which is stored at current pointer, and then we'll print dot data. Why dot data? Because this is the object that we're creating with two properties, data and next node. So in order to access, I have to go to each index. This would be index 0, and in order to get the data out, I need to write dot data. If I need to get to the index 1, then index 1 dot data, I'll get 5. Then index 2 dot next node, I'll get 7, so on and so forth. So this will print the value, and then I have to go to the next pointer now. So how do I go to next pointer? If I'm at next node 1, if I'm at index 0, I'll just read the value of next node and assign it to the current one, because now 1 will be my current pointer. Then after 1, 4 will be my current pointer. So this is what we're going to do. We'll say current pointer becomes equal to linked list, whatever the current pointer was pointing to lastly, and its next node. Simple. So if the current pointer was pointing to 0, now at 0, the next node is 1. So current pointer becomes 1. Next time we'll check, is 1 equal to not minus 1? No. Then at index 1, the next node is 4. So at index 1, this becomes 1, and this whole thing is replaced by 4. So on and so forth. Simple enough. Then in the part after that, they're saying that you have to edit the main program to call the procedure output nodes, and you have to take a screenshot of this. So we'll call the output nodes. Output nodes, we have the linked list here, and then we have the start pointer set to this, and then we'll run the program. Okay, it prints all the values 1, 5, 4, 6, 7, and it ends on 7 because at 7 the next node is set to -1, which is end of linked list. So we are not going to go further at this point, even if we have more nodes. Then they're saying now you are supposed to write a module that is called add nodes. This is going to be a bit complicated. Okay, so in the add nodes, what we're going to do is we have defined add node. We have the linked list here. Then we're sending the start pointer, and then we're also sending the empty list pointer. Okay, what are we going to do? They're saying that it will take these parameters, then takes the input and add it to be added to the end of the linked list. Function adds the node in the next available space, updates the pointers, and returns true. If there are no empty nodes, it returns false. All right. Now the total size of the linked list is 9. So if our empty list becomes at any point greater than 9, then that means that there is no add node can be added. Let's do it step by step. Let's call it new item or new data maybe. Let's call new item with no int input, enter value, add in linked list. And then we check if the empty list at any point is greater than 9, then we have to simply return false. That is what the question is saying. Let's go back. Takes it, and the function returns at the node in the next updates true, and if there are no empty nodes, it returns false. So that is what you've done already. Okay, now once this is done, then they're saying you have to basically output the appropriate message depending on the result, and then call output nodes twice, once before the add node and once after. Okay, now we have to add the node at the end of the linked list. Now that means that we simply have to go to the empty list that is pointed to by this empty list pointer in our array, and we store the values there. This empty list is telling you where the next value will be stored. And end of linked list simply means that we go until we see this -1, and once we have the -1, after this -1 we will add the new node and we will assign the next pointer to it. So let's say if we have 7 here and 7 is the end of linked list, maybe the next value I want to store is maybe 56. So then 7, the next pointer will not be -1, instead it will be pointing to index 7 now, row 7. And then the next of 56 will be actually set to -1 instead of 3. This is what we have to do, and we'll write code for that. Okay, first of all, wherever we have to start from, or wherever we're going to store the free node in, that we'll call the, let's call it free list, and we'll point it to the empty list. Now what is empty list doing? Empty list is storing the index of where you have the next available space, which is at index 5. It is set to 0 right now. So I'm copying it into a free list. So we have a copy, and we can refer to empty list later on. And then I'm going to update the value of empty list. The reason is that at index 5 now we're going to place a value, so it will not be free any longer. So what we have to do is, whatever the current free list is pointing to 5. So instead of 5, now I'm going to go to 6 for the next available space, right? Because at 5 we'll be placing a value. So for that I'll do linked list wherever the empty list was pointing previously, and then I'm going to go to its next node like this. So if the empty list was pointing to 5, I'm saying go to index 5 and go to its next node, which is at 6. So now the empty list is going to point at 6. And that is where the next value will be stored. That's the idea. But that is why we have already copied 5 into our free list. This is where we're going to be adding the new value and updating the pointers. Then we are creating the node new item that we had. This was the data value, so we have to convert this into a node object, and let's call it new node, and new node is equal to node, and we have the new item, the data value, and then we are going to set it to -1 because this is just a new node. We haven't updated the pointers yet. Okay, this is done, and now we're going to paste or put it in the linked list. Now we have the free list pointer here, so we are going to go ahead and place the value at the free list index, and this would be the new value that we just created. This is the new node. So what we're doing here right now, our empty list was pointing to 5, and we're going to go ahead and we're going to place the new node here. And then before that, we had already set the empty list to point to the next index, which was pointing to 6. So empty list is now pointing to 6, not 5, and we are going to store the new value at index 5. Okay, till this point we're done. Then we're going to move forward now. And in the next part, now we have to go to the end of the linked list, and that is what we have already seen how to do that. But in this case, we would actually need two pointers. One would be the current one, and other one would be the previous one. Now the logic for that is when we go to the last pointer, let's say you're at the last index, which is 7 and -1, you are supposed to add a value after this, right? And until and unless you don't know where you reached to this point or where the next node will be inserted, you wouldn't be able to do that. So that is why we need two pointers, current pointer that will be pointing to the last node, and then the previous pointer that will be getting pointing to the previous value that you came from, which in our case would be the 76 and 3. Okay, so I'll write current pointer. I'll set it to the start pointer now. The same logic that we used above. We will make sure that we always start from the start, I guess. Once this is done, then we are going to set the previous pointer to 0 because we do not know where the linked list is starting from. So we can just assume 0 for now. And then we are going to run a while loop. So while current pointer is not equal to -1, while the current pointer is not equal to -1, we will make sure that we are setting the previous pointer to the current pointer. Now the reason is that if we are starting from, let's say, 0, this was currently the previous pointer, and now when we go to index 1, this becomes the current. So data 5 is current, and then 1 is previous. Then from here we go to row 4, so data 2 becomes current and data 5 becomes previous. So every time, whatever the value of current was, it becomes previous when we go to the next node. Okay, once this is done, then we are going to go ahead and we have the previous pointer here and we set to current pointer. Okay, then I'm going to update the value current pointer, and just like we did before, in order to do this, we will simply just do linked list. Whatever the value current pointer has as an index, we'll just go to its next node. Again, what's happening? So if we're at data 5, the next node is 4. So we'll set the current to 4. Once this is done, we would have reached a point where the current pointer has become -1. And when it has become -1, again, when we have 7 here and when we have -1 here, now we're going to add the value at the end of the linked list. So in order to do that, I'll simply go to the linked list and I'll go to the previous pointer and I'll set the next node to the free free list. Okay, what did I do here? So if I'm going to add a new value here at index 7, now what I have to do is I have to update the value of data stored at index 3 and I have to update the next node to 7, or in our case it would be basically 6 because 6 is the next available value. And this is what we're doing. We're saying we had 6 in the free list and we're saying whatever the previous pointer was, previous pointer would have been pointing to the value that we have here, and then we're setting its next node, which was currently -1, and we set it to the free list pointer, which is equal to 6. So now this will point to 6, and then the new value that we stored here, if we already set its next index to -1. Also, like this, we are setting the next node here to 6. So the idea was that wherever we find the last node, we are going to stop and we'll go to the node previous to it, and then we're going to update the pointer because now the last node will be updated. So we'll change it to previous value, which was free list, and then at the end I will simply return true because I have added a value in the linked list, and that is it. Okay, then they are asking us to continue further. They're saying you have to call add node. Okay, and then you have to output appropriate values. So first of all, we'll output the nodes. Then we're going to get a response from add node. We will pass all these parameters and then we'll check if the response came out to be true. Then that means you have added the value. So we'll say print node added successfully. Otherwise, we'll say that node added addition failed. And if it was added successfully, we'll call output nodes again with the pointers that they passed. Node addition failed. And let's try. Okay, here we go. So we are adding 18. The last value is 7. So 18 goes after 7, and that's it. This is the complete program.